Okay, so here's the second problem, and as you see on the right here, my attempt to draw Thor's hammer, and that will all make sense in just a minute. So in this section, we're going to draw models to solve ratios with three quantities. And we talked a lot about earlier about how ratios were comparing two things. And so what I was thinking about was it's kind of like the transitive property that you're going to learn more of in algebra. So that's not something you need to write down, but it's just kind of a file in your brain to help you think about this whole three ratio or ratios with three quantities thing. So the transitive property says if A equals B and B equals C, then A equals C. So all that's saying is if you have two things that are equal and one of those things is equal to a third thing, then the first and the last are also equal. So with comparing three quantities of the ratio, it's kind of like the middle quantity, like here that we're going to look at the problem, is what allows you to compare the first and the third. And the reason I drew Thor's hammer is that there's a TV show I watched where one time they were talking about about who could pick up Thor's hammer. And if Thor picked up his hammer and then Hulk picked up Thor, then by the transitive property of picking up things, Hulk would have picked up Thor's hammer. And I thought that was a funny way to think about it, because obviously Hulk can't pick up Thor's hammer, but if he picks up Thor, who has his hammer, then he, in effect, has picked it up. So I thought that was funny, and kind of a funny way to think about this whole comparison of three quantities. So let's look at this problem. It's actually not that hard. So Jenny makes a glazed mixture of feldspar, red iron oxide, and silica. And I obviously forgot to write the word Jenny makes. And the glazed mixture is just when you make pottery, you have the clay that you harden, and then you put the glaze on top, and you put it in the kiln to fire it again, and that's what makes the nice shiny coating. And I think the different colors, minerals, when you heat them, it creates different colors. So they tell us here that the ratio is 5 to 2 to 3. So this is feldspar, red iron oxide, and silica. And that the mass is 1 kilogram, 200 grams. And what we were supposed to find is the mass of each ingredient. Now, I forgot in this situation to do what I know, what I need to know from yesterday. But this essentially is what I know, that the ratio of feldspar to red iron oxide to silica is 5 to 2 to 3. And what I also know is that the total amount the total mass is 1 kilogram, 200 grams. So again, since we're in the Singapore math book, we're using our bar models. And so here I draw a bar model. Of course, I didn't draw it perfectly. Not all the units are equal, but they are meant to be equal. So I have 5 units or blocks for the feldspar, 2 for the red iron oxide, and 3 for the silica. And why I colored this in red will make sense in a minute. But here, since I have kilograms and grams, in order to divide, I'm going to need to put them all in grams, put the whole quantity in grams. So what I did over here was just a reminder that 1 kilogram is 1,000 grams. So I have 1,000 grams here, plus 200 grams is 1,200 grams total. And we're using the same strategy that we did before, where we use the parts to find the whole. So since I have 5 plus 2 plus 3, my total units is 10. So I'm going to divide the total amount by 10 to find the value of 1 unit. So that's why this is colored red. So I'm finding out the value of 1 block, what that represents, and it's 120 grams. So solving is pretty easy because I know that 5 units are feldspar. So 5 times 120 is 600, 2 times 120 is 240, and 3 times 120 is 360. So just a little aside here, just to liken this to what we did yesterday. If I was going to do a table, I would have an extra column here. So I have the feldspar, the red iron oxide, and the silica, and here's my total. So what I did yesterday was I added 5 plus 2 plus 3 is 10. And then I know that my total is 1,200 grams. So I'm essentially finding a part to whole equivalent ratio. So my first part to whole ratio would be feldspar to the total. So 5 to 10. So that's what this one is. 5 to 10 is the same as blank to 1,200. And so since I have to multiply by 120 here, I multiply by 120 here to get the amount of feldspar. And then I would do the same to fill in the red iron oxide and the silica. So essentially I'm taking the part to part to part ratio that I was given and creating part to whole ratios. Okay, so that's the second problem. And I'm going to pause or stop this video, and then I will load it on Portals or on YouTube, and then I will share the link with you guys on Portals shortly. And remember, we have 2 more to finish today's problem solving.